In the previous video, we saw a summary of what quartiles are and then what interquartile range is. Hopefully you've written that down in your notes somewhere, but we're going to do a little more with that. And then just to reiterate, we have here a summary of what you should have gotten from this module so far. First, the 5-number summary uses quartiles to identify the center and spread of a distribution. So remember that the quartile the 5-number summary includes the minimum value, so the lowest of all the data values, the highest value in quartile 1, the highest value in quartile 2, the highest in which they use as the center. So you might not even see Q2, the highest value in quartile 2. You probably just see center. And then Q3 is the highest value in quartile 3, and then Q4 you wouldn't see that much. You'll see that referred to as the maximum value. And then the median, which is Q2, like we were talking about, is a measure of center. So they might call it median, they might call it center. We also view the median as a typical value that represents a distribution. And then also that the values between Q1 and Q3 give a typical range of values. The interquartile range, or IQR, is a way to measure the variability about the median. Now let's try an example. We use the 5-number summary to make a new type of graph, the box plot. Box plots are commonly used to summarize a distribution of a quantitative variable. So I think we kind of saw a box plot maybe in the previous video. It was kind of like a dot plot, so you see a dot plot, but you see the quartiles cut off based on kind of color. They use white and gray to signify the end or the beginning of one quartile or the next. So yeah, let's look at that. Let's see. So here's an example for exam scores. Let's see here. Here are 2 sets of exam scores from the previous example. Recall that we divided the data into quartiles. In a data set, each quartile contains the same number of scores. In other words, each quartile contains 25% of the data. So basically, we haven't had to come up with our own quartiles yet. I guess we're assuming also that the number of data values is divisible by 4 so that we can divide it into 4 quartiles. But all you would do is list the data from smallest to largest, and then divide those values by 4. The smallest equal sized group would be quartile 1. And then the next that had the second largest values, or sorry, the second to the smallest values. So I don't know, something, even maybe just a simple example just to illustrate. Before we even jump into this exam thing, like if you had values of 2, I'm just making these up, okay, 2, 7, 9, 10, I don't even know what these signify, I'm just making it up as I go. 15, 16, how many is that? And then 20 and 32 or so, whatever. Those are 8 numbers, I believe. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. And if someone said, okay, I want you to do a box plot of these numbers and whatever, they signify something in real life maybe, but all you would do, okay, they're from smallest to largest, 2, 7, 9, 10, on and on. So then you just say, okay, how many values are there? There are 8 values. So I can cut them into, oh shoot. Sorry about that. Somehow I lost all those numbers. So you just say there's 8 of them. If I cut those into 4 groups, there'd be 2 in each group. So the 2 smallest go in one group. The next, kind of like the second smallest group, is quartile 2, and then quartile 3 and quartile 4. So that would be a very simple example of breaking data into quartiles. Here's quartile 1. This box represents quartile 1, quartile 2, quartile 3. In this case, there's no repeats. All these numbers are unique. I don't have 2 of the same number, but that would be it. So in this case, the minimum value here is 2. It's 2, and then Q2, or let's see, yeah, there's that guy, and then Q1 is, in this case, there's not a lot of numbers, so the highest value in quartile 1 is 3, that's Q1, and then Q2 would be your, this one, in this case, they're even numbers, so the median would be the average of these two. Remember, if it's an even number, there's no middle value, so we average the 2 middle guys. 9 and 10 added together divided by 2. So basically, the median is the mean of the 2 middle values. equals, yeah, so 9 plus 10 is 19, divided by 2 is 9.5. So that would be your median. And I think we saw that in a previous video, that your median doesn't even have to be a value in your data set. And then so we got Q1, median, and then Q3 would be the highest value in the third quartile, and then Q4, or they don't call it Q4, I'm sorry, they call it the maximum. But whatever, same thing, is 20, that's the highest value. That's, anyway, a simple example, just to illustrate kind of what we're doing here. But this, we're going to move on now to the more complicated one. So here's the 5-number summary of these two distributions. So it's a bunch of so we're talking about two different distributions. There are this instructor is teaching two different classes. One of them, in class A, the minimum score there was 40, and the end of quartile 1 value was 71. So a quarter of these values are in the first quartile. The very smallest in that quartile is 40, the minimum, and the highest in that quartile is 71. They're pretty far apart. And quartile 2 ends at 74.5, which isn't very far from the end of the very rightmost point of quartile 1. That must mean there are a lot of values in quartile 2 that are around the same range, or the same area. Quartile 3 ends at 78.5, which is not much larger than the quartile 2's ending point. And then the maximum value is 95. And then on the other hand, though, in class B, the minimum value was the same, 40, but quartile 1 ended at 61. So there must have been more low scores in this class rather than class A. But quartile 2 ends at the same place quartile 2 ended in class A. Quartile 3 actually ends at a higher value than quartile 3 did in class A, but the maximum value is the same. So it looks like maybe the values in class B are more spread out, more low scores, more high scores. They're not all centered around a C grade, I guess, a 70 something. So let's see. To create a box plot for each of these distributions, we draw a box plot from we draw a box from Q1 to Q3. We draw a vertical line in the box at the median. We extend a tail from Q1 to the smallest value that's not an outlier, and from Q3 to the largest value that's not an outlier. And then we indicate outliers with an asterisk. So here, they have asterisks here, 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 it looks like. So those must be further from the center than Q3 minus Q1, I think. Isn't that how we defined outlier? Outlier was if the value, if you think it's an outlier that's larger than all the values, then that value must be larger than median plus, was it 1.5, the interquartile range. And remember, interquartile range was Q3, the largest value in the third quartile, minus Q1, the largest value in the first quartile. Either that, or if you think it's an outlier that's very small, to the left, very far to the left of all these values, that value must be smaller than the median minus 1.5, the interquartile range. So I'd probably, if you were trying to figure that out, what's a outlier, what's not, figure this out first. What's the interquartile range? The value of Q3, which you could see here, minus Q1. That's for class B anyway, but for class A it's going to be different. Okay, so they've already done that for us, just in case someday you ever have to do that. Let's see, oops, I messed up. Where'd I go? Here we are, okay. So they've drawn the box plot for us. A long box in the box plot indicates a large interquartile range. So the middle half of the data has a lot of variability. A short box in the box plot indicates a small interquartile range. In this case, the middle half of the data has less variability. Frequently, side-by-side box plots are drawn vertically, so you see one box plot above the other. Here we drew vertical dot plots with their box plots for the example scores, for the exam scores from the two classes. So yeah, notice as they were kind of saying, in class A, you see, let's see, here we go. the first quartile in Class A is has a very wide range. I think it went from 40 to 71. So that's why this first box is so wide. The second box, or the second quartile, is going to be very small. It was from what, 71 to 74.5. That's why this little next kind of shaded area is so narrow. And then quartile 3 went from 74.5 to 78.5, very narrow as well. And then the last quartile was large because the difference between 78.5, which is Q3, and the maximum value, which is 95, is large. So there's not as much variability in Class A as there is in Class B, because you can just tell the middle quartiles, quartile 2 and quartile 3, are wider than they were in the first example for Class A. So let's see. Then what did we say? Side by side. Yeah, here's the side by side box plot. Frequently, side by side box plots are drawn vertically. Here we drew vertical dot plots with their box plots for try to say that 5 times fast. With their box plots for the exam scores from the 2 classes. Okay, so you can kind of, determine if you like to see them vertically this way or horizontally. I guess just whatever you get used to is probably what you're gonna like. So I don't know if this is better or worse, I guess, so that you see Class A is here, Class B is there. It's kind of like they just rotated the, it's almost like they rotated this box plot 90 degrees, and then it looks a lot like the one down here. I don't know why you would do that. Maybe sometimes it's easier for people to see visually. It probably depends on who's seeing it. Let's note that some statistical packages offer 2 options, a box plot and a modified box plot. We drew modified box plots in the example. In a modified box plot, outliers are marked with an asterisk. For a box plot that is not modified, the tails extend to the minimum and maximum value. In this type of box plot, we cannot see outliers. So that means a modified box plot gives you more information. Yeah, like they said, it shows outliers. So that might be something to write on your notes if you're taking notes. It shows a modified box plot shows outliers. A regular box plot does not. Yeah, I should say indicate. I'm sorry, not shows, indicates. Just because either way the outliers will be there on the plot, but you won't know which ones are outliers and which ones aren't, I guess. If that's important to you. Does not indicate outliers. Yeah, you'll see them in your box plot, the values, like, so here's an outlier, no matter what you'll see them, but whether there's an asterisk or not, or some kind of way to label which ones are outliers, which ones aren't, that's the difference.